So now I am ready with my new project. The project name is reset sequence, and I just added the startup files and the QMSys code. That's fine. So now I'll just add my main.c, add new item, C file, and let's add. Great. So this is empty.c file, isn't it? So I'll just write one function, main. Great. So does it compile? Let's check. Yes, it compiles. Great. So now let's download. Yeah, it downloads. So now the code is stored in the flash memory, isn't it? Okay, so there is nothing great about that. Now what I do is I put the board into debug mode. Okay, and you can see that as soon as I put the board into debug mode, the control has reached to main. All right, so now let's again reset the processor. So from this option also you can reset the processor. And as soon as I reset the processor, you can see that the control actually first came to reset handler. So let's check our discussion. Okay, when you reset the processor, the PC is loaded with the value 0. Okay, so this we cannot observe because that happens as soon as you issue a reset signal. The processor reads the value at memory location 0 into MSP. Right, so that we can check. You can see here the MSP is showing this value, so that means this value has to be present at this location, isn't it? Right, so that we can check. So what I do now is I just open the memory window and I just look at the address of 0, and here it is. The 0 indeed contains 2000660. Okay, so that value is indeed copied into the MSP. So that means this has already happened. So now after that, processor reads the value at memory location 04. So let's go to 04. Now take a look into address 04. So in the 04, as we discussed, the location 04 contains the address of the reset handler, which is 32-bit. That means 4-byte wide address. Okay, so we have to read 4 bytes here. This is nothing but the address of the reset handler. So 08, 00, 02 and 0D, and this address will be loaded into the PC. So look at PC. So PC is indeed loaded with that value. So you will find this 0D as 0C. So it has some special meaning, so that I will cover later. And if you just hover the cursor over here, it indeed shows that reset handler is at location 0800020C, and that is loaded into the PC. That happens automatically. Now the processor is in the reset handler, right? And this reset handler is implemented by you. Okay, but in this case we have not implemented this, but it is given by the startup code. So since I have included startup code of this microcontroller, the microcontroller vendor is already written it for us. If you exclude this startup file, then you have to write it. And in the reset handler, the manufacturer is doing some system init. That means he is calling some system init function, and then after that he is calling the main function. And in the main.c, which is created by us, we have one main function here. Okay, so note that this main function and this main function, they are not same. Here this code is calling a main function which is there in the C library. It is in the library format. Okay, first it goes there, and from there it comes here. And calling of this main is mandatory, or it is required actually, because it does some of the memory related initializations. That means it copies data from flash memory to the RAM memory, it initializes the BSS, etc. So it does some memory section related initializations, which is automatically done by the library code. So that's why you may have to call this. Okay, so if you don't want to call this, then all those functionalities you have to implement by yourself. Now let's not get into that. So just call the __ main function, and from that it reaches this function. And take a look here in front of this reset handler, okay, which is actually an assembly routine. The manufacturer has mentioned that it as a weak function. Okay, so that means he is giving you an opportunity to write your own flavor of this reset handler using the same name. You can have another flavor of the same function in your code. So now what we'll do is, so we will again implement this code as a C function. So I will use the same function name in my main.c. Okay, so what I will do is I'll just implement here. Okay, reset handler. Let's implement it as a void function. Great, so now we have overridden the reset handler in our file main.c. So now just compile this and see what happens. Okay, so let me just go to the debug mode, and yes, the control now came to reset handler, so which is implemented by you. Whenever I press reset button here, okay, the control comes to the reset handler. This time it didn't go to this function. So now what we'll do is now we will implement, okay, all these things here in the reset handler which implemented by us. So what they are doing nothing. They are just calling two functions. So let's call this from our function. Okay, first call this function. Okay, here this function, copy paste, okay, and then again call this function. Great. Okay, so now the key is not able to resolve these symbols. Okay, so because these are actually implemented in some other source files, right? So for example, system init is actually implemented here, so we have to just give the signature of that function. So just copy this function name and make it as extern. Great. And for this also, okay, extern int main void. All right, compile it. Any errors? No, there are no errors. That's great. So now let's again download, and let's keep a breakpoint here, and let's debug this code. And yes, here you can see, okay, it came to our reset handler, right? So now I execute this, and whenever I execute this function, it goes to the compiler specific initialization code where it initializes various memory sections and all. Then finally it calls the main function. So now it actually comes to this function. Okay, let's see that. Now let's hit run. Here you can see the control reached to main function, and here you can implement your application. And in reset handler you can do whatever you want, but at the end you call this __ main. That's it. So here I'm calling my microcontroller specific initialization code, which is given by the vendor. So that's how the resetting of the processor actually comes to the reset handler. Then from reset handler you reach to the main function of your application. So in all our application we need not to implement our own reset handler because it is already written in the startup file. So that's the reason we actually include the startup file with our project. So not only reset handler, it contains primary handler for almost all exceptions. Okay, if you want to override that, then you just copy that function name and write in your application. All right, so that's about the reset sequence of the processor. And if you have any questions or if you have any doubts, let me know. I'll be very happy to answer and clarify all your questions. Okay, great. So I'll see you in the next lecture.